Have you ever pondered the critical role the ozone layer plays in our environment? This seemingly invisible shield high up in the Earth's stratosphere is a vital protector of life as we know it. The ozone layer absorbs the majority of the sun's harmful ultraviolet radiation. Without it, this radiation could cause serious harm to most life forms, especially to creatures at the bottom of the food chain, like plankton, and we all know how that could ripple up, affecting all of us. Now, you've probably heard about the depletion of the ozone layer, a global concern that prompted worldwide action. The Montreal Protocol, for instance, was a landmark agreement that successfully reduced the production of ozone-depleting substances. It was a global handshake for the health of our planet. But the story doesn't end there. Despite our efforts, the ozone layer's health is still a subject of global concern. Recent developments, however, raise new concerns about the state of our ozone layer. Over the past 3 years, large ozone holes have disturbingly made a comeback over Antarctica. This unsettling resurgence carries significant implications for climate variability in the southern hemisphere. Let's delve into the factors contributing to these changes. Firstly, temperature plays a key role. Fluctuations in atmospheric temperature can influence the formation and size of these ozone holes. Secondly, wind patterns also factor in. Changes in wind can transport ozone and other chemicals, affecting the distribution and concentration of ozone in the atmosphere. Thirdly, aerosol loading comes into play. Aerosols, tiny particles suspended in the air, can influence the depletion and creation of ozone. Lastly, greenhouse gas emissions contribute as well. These gases, particularly carbon dioxide and methane, can trap heat in the atmosphere, leading to conditions that foster ozone depletion. Despite the Montreal Protocol's success in reducing ozone-depleting substances, these other factors continue to impact ozone recovery. This unexpected resurgence of ozone holes prompts us to question the projected timeline for ozone recovery. The 2022 scientific assessment of ozone depletion had given us hope with a projected recovery by 2065. This forecast was a beacon of optimism in our fight against environmental degradation. However, recent findings suggest that we might need to adjust our timelines. It appears that unaccounted releases of chlorine, a major ozone-depleting substance, might delay the healing of the ozone hole. Despite the concerted global efforts to reduce ozone depletion, notably the Montreal Protocol's success in curbing the use of such harmful substances, large ozone holes continue to form in recent years. This persistence is a stark reminder of the complexity of our atmosphere and the challenges we face in preserving it. The research we're discussing today has delved into the behavior of ozone during the spring months. Here, a mixed picture emerges. September, typically the peak of the Antarctic ozone hole, shows signs of recovery. The ozone layer is bouncing back, hinting at the impact of our mitigation efforts. However, this optimism is dampened as we move into October and November. During these months, a negative change in ozone is observed, indicating that the hole isn't closing as fast as we'd hoped. It's as if the environment is pulling a cruel magic trick, showing signs of healing one moment, then reverting back the next. Moreover, there's a delay in the onset and breakup dates of the ozone hole. This means that not only is the hole lingering longer than expected, but it's also appearing later than usual. What does all this mean for our planet? Quite simply, it's a call to reevaluate. These findings challenge our understanding of ozone recovery. They underscore the necessity to consider the impact of emerging sources of chlorine, along with the ever-looming threat of climate change. So while we've made strides in our battle to mend the ozone hole, it's clear that we need to stay vigilant, adapt, and refine our strategies. Our understanding of the ozone layer is evolving, and so too must our approach to its preservation. These findings challenge our understanding of ozone recovery and emphasize the need to consider the impact of emerging sources of chlorine and climate change. So what have we learned today about our ozone layer and its recovery? We've delved into the importance of the ozone layer, that invisible shield protecting us from the sun's harmful rays. We've explored the concerning re-emergence of large ozone holes over Antarctica, which holds significant implications for climate variability in the southern hemisphere. Our journey has taken us through the factors affecting ozone recovery, beyond the reduction of ozone-depleting substances. We've learned that temperature, wind patterns, aerosol loading, and greenhouse gas emissions all play a role in this complex process. Most crucially, we've examined the potential delay in the projected recovery of the ozone hole, initially foreseen for 2065. Recent findings suggest that unaccounted chlorine release and climate change may push this date further into the future. This brings to light the importance of continuous research and monitoring of our ozone layer. It's a reminder that our actions have a profound impact on this vital global asset. To continuously be enlightened, like and subscribe.